So I want to look at another question using the quadratic formula, but I want to show you something. Remember, it has to be in standard form. And look, this isn't in standard form. In order to be in standard form, everything's got to be on one side of the equation, and it has to equal to 0. So that means you have to move the 12 over. Well, that's fine. That becomes x squared minus 6x minus 12. Now, that equals to 0. Now, at this point, a lot of people say, well, why don't I just use PSA? Because, I mean, after all, this is a small PSA 1. You should be able to crank out the answer for this real quickly. Well, let's use PSA, and let's find out what the answer is. Product here is minus 12. Sum here is minus 6. Two numbers to multiply to give me minus 12. Well, let's do it. 2 times minus 6 or minus 2 times 6. You have 4 times negative 3 or negative 3 times 4. You have 1 and 12. But if you notice, not a single one of these, not a single one adds up to minus 6. So when we were doing this originally, like in grade 10 and stuff like that, we would say that this is not factorable and you'd have no roots. Well, that's a lie. Because if you actually take this and put this into your calculator, I want to show you, you will actually get 2 roots. So 2 roots then just aren't nice numbers. That's all. And that's one of the reasons why I put up here, express the answer as a decimal and in radical form. You're going to get really ugly answers. I'll prove it to you. I've got the calculator right here. And I just happen to have the formula in the calculator already. Hit graph and look. You in fact will have 2 roots. You'll have a root here and you'll have a root here. Even though it doesn't give you a possibility of doing it this way through PSA, there are in fact 2 roots. The graph does not lie. The only difference is these roots won't be pretty numbers. They'll be ugly numbers. They'll be decimals and so on. PSA, this kind of method, allows you to find out nice numbers, nice whole numbers, or nice negative integers, but not decimals. That's the limitation of PSA. That's why the quadratic formula of minus b plus or minus square root of b squared minus 4ac over 2a becomes incredibly handy. Very, very handy. So, wait a second. What's what here then? Well, remember which is which. That is your a value. There's your b value. There's your c value, which means just substitute it in. So here we go. Let's start here. Minus b. So minus, your b is already negative, so minus 6. You have to do the double minus, otherwise you're going to get the wrong answer. Plus or minus the square root. Again, minus 6 squared minus 4. Your a is 1. It's 1. Your c now is minus 12. Minus 12 over 2a. 2 times 1, which I think is just 2. Okay, so what I always do when I do a question like this is I figure out what's underneath the radical sign. That's this guy right here. I figure this guy out first. So I bring up my calculator, okay, clear this, okay, let's get rid of the 2 targets there, perfect, and let's start using this, okay, bracket, minus 6, bracket, squared. Don't forget the brackets around the negative, because remember, if you don't put brackets around the negative and square it, it'll give you a negative number back. Okay, and we know negative 6 squared is negative 6 times negative 6, which is a positive 36. Minus 4, okay, times 1 times a negative 12. And let's see what the answer is. I got an answer of 84. All right, so let's clean it up. So this is minus minus, which makes the positive 6 plus or minus the square root of 84 over 2. Now, hold on a second. We can clean this up a little bit more. That 84 has to be able to be broken down. So let's break it down using our factor tree. Remember, 2 times 42. Okay, you can do it again, right? Times 2 times 21. Oh, that's nice because look what happens now. This gives you 2, that gives you 2, that gives you 7, that gives you 3. There's your pair, meaning that this is 2 square root 21. That's it. There's your radical. So this guy becomes here 6 plus or minus 2 root 21 over 2. Now, you could, at this point, if you needed to find the decimal, which we have to eventually, okay? We have to figure out the decimal eventually, but I want to look at the radical form first. I want to leave this in this form first. Now, notice 2 can go into 6 and this 2, leaving you a 3 plus or minus root 21. That is your answer in radical form. Okay, and if you want to do the decimal form from this, that's easy. That'll be 3 plus root 21. That'll be 3 minus root 21. Let's figure out what root 21 is. Okay, I'm bringing up the calculator here. Figure out what's root 21 right now. Second square root 21. That's going to give us, look at that, 4.58. So this is like saying 3 plus 4.58. This would be 3 minus 4.58. And of course, the problem with that is it's a rounded number now. This works out to be 7.58 is one of them, and the other one is 3 minus 4.58, which works out to be negative 1.58. So there's my two numbers here and here. I want to go and look at this again on my calculator here and see if that actually makes sense. Look at this. Look at this. Negative 1.58 is right there. Look at that. That in fact is negative 1.58. Look at this one. Look at this. That is 7.58. How do I know? 1, 2, 3, 4, 5, 6, 7.58. There it is. So I know the quadratic formula actually gives me the right answer. Again, you can do this in radical form, or you can do it in decimal form. Either way, check the question. It'll tell you the way it wants the answer. But this is just awesome.